Okay, hi. Here I would like to demonstrate how my R could run well in this assignment. So yeah, I'm using R Studio to create my R programming, and then I will prove that my code is running well. So first thing first, I will I will remove all the global environment here to start from zero with this code. So now it has been removed and we can run the code from zero. So first thing first, the code that will be run is code for data frame zones. So I just copy this for creating data frame zone with column zone ID with the value A, B, C, D, E, F, G. And then this code for adding other columns like class, altitude, and vegetation value. So just copy this code and then run here by copying and paste. And then I click enter. So it has been created zones with 7 rows. To code it, just call the variable and it's created. And to show the advance of our programming that can be integrated with SQLDF, here I also can store my zones data frame into CSV file and then call with SQLDF. I copy and paste here and then click enter. And then the windows will be showed up. To choose the file that I have been created, so it is zones.csv, so I just select zones.csv and then open. Yeah, it has the same value as this one. Okay, that's for zones. Okay, now we are going to the second data frame, which is animals. Here, to show the advance of studying distribution and applying it into R, I use two distributions that are different from the distribution that has been explained in the class before. So here I use a triangle for height of direction because there is no information in the equation. So I use a different distribution. And then the second one is I use Cauchy distribution. Because I use triangle and it has not been installed in the R package when I use RStudio. So first thing first is I have to run this code. But actually, I have explained about triangle distribution in the report, and it can be found in the explanation of height. So basically, triangle distribution is a continuous probability distribution that shapes like a triangle, and it has been known for its size of observation, minimum value and maximum value, and also the p-value or mode. So it is suitable for describing the heights of direction. Meanwhile, on the other hand, for the mass of zero, for the mass for 0, there is also no information in the question, so I use Cauchy distribution here. Cauchy distribution basically also a family of normal distribution with taller peak. And the expected value and the other moments do not exist, but the median and mode do exist. So I just need to describe the median and mode for the Cauchy distribution. Okay, now we're back to the code again. So first thing first, I will run this R triangle code. Just copy it and paste into R. Okay, it has been run here. So the R triangle already available in the global environment. And then creating a data frame for animal. basically in here I use split and unsplit because here I created 3 species and every species has its own data, so I split the data for the species and then reassemble again. After that I adding a column to every species with looping, and here I put our triangle in DirectGIF, I think. Oh yeah, in here, our triangle. And for the zero, I put our Cauchy here. So I just run all the codes in once. This is for the symbol. Again, I also store my data frame into CSV file and then recall again using SQLDF. Just copy paste and run. Yeah. This is for the SQLDF because I read from the CSV file, so I just need to read the file names animals.csv. $200 object. Here, if I use SQLDF, but actually I can also use just R programming. Oh no, this is for the SQLDF, and if I want to run with normal R programming, it's still okay. I just call the variable. Yeah. It's obviously the same. Okay, this is for the animals. And following the animals, run on. Okay. Following the animals, we can run the weathers here. So basically, all of this has been explained in the report. So I just demonstrate how this code will be run. Copy and paste it. I will call weathers.csv. Yeah. Like this. For weathers. And the last data frame is events. For events, I recommend to run the code part by part. So the first part is about creating a data frame with 1000 rows. Actually, I assume 1000 is enough for observing the data and I mean for recording the animal's behavior, whether it attack or it. So first thing first, I create 1000 rows here, and in every row I take predator ID from animals table, and to ensure that predator ID is not the same with prey ID, because it is impossible for two same animals to do attack or it, so it should be different. And I use not in predator here. Then I insert predator ID as the animal's ID instance, and predator species here. Actually, I don't need to insert this predator species in my data frame of events. I just make sure that this behavior is inserted to my data frame events with this condition. If species is DirectGIF and the prey species is 0, so the event will be it, as well as the predator species is GIF and the prey species is 0, so the event action is it. But for other animals' behavior between species is attack, whether it's the same species or different species. And finally, I also included weather ID. that is taken from weathers, table weathers, and column weather ID. With calling this weather ID, actually when I do a join table, I can call the location where the events happen and what is the condition of the zone or the location that the event has occurred. So basically this is for the code part 1. We can just run. Yeah, so we recorded. And like previous code, I also, as previous code, I store into into CSV file and then call it SQLDF. Then with event 1. Why we have to run this code by part? Because I will call for database, for data frame, and or for tables, because I need the relationship for all 4 tables here. So I call one by one. Then for weathers, animals, okay. Yeah, and this one. This is for calling species from animals ID, and then calling also the prey species because I didn't store this species into my events database because it doesn't require it. We can call from the animals with the predator ID and prey ID that has been stored into events. Yeah. Okay, now we can see the join table result here. So previously in the events table or data frame, we just have predator ID, prey ID, and then action, and also the ID of the event itself. So basically, from the join table, we can also call species for predator ID and species for prey ID that coming from animals data frame, and then date, time, event zone, location, temperature, and condition taken from weathers table. If we need to add more information, we just add in here, add the column name, and then the condition for joining all the tables.